Hello everyone and welcome to another video of Vivek Learns. So in this video series we'll continue solving the recursion problem. So in the last recursion video we had solved this recursion problem where we had kind of set the expectation to find the power of a number. Like we were given two numbers x and n, and what we had to find is x raised to power n. So we had set the feed that we already know x raised to power n minus 1, and um, that is how we bridged from faith to expectation using this formula, and then we could find the current power, right? And let's now try to solve this in a more optimized approach, right? So what we can do is that we have this, and what we had set the expectation for the last time is, let's say we found power of 2, we want to find the power of 2 comma 5. This was our expectation, and we had the faith that we know power of 2 comma 4. 2 raised to 4 means it's 4 times 4, it's 16. And then what we used to do is we simply used to multiply. How do we bridge? How do we bridge from expectations to faith was x times power 2 raised to 4. And like we can write something like power of 2 comma 5 is nothing but 2 times, right? And this is how we wrote the general formula. Power of x comma n is nothing but x times power of x comma n minus 1, right? So this is how we had set up the base case for the this problem. So the base case was that for when n is equal to 0, then we return 1, because any number raised to 0 is 1. So what extra can we do? Like, mm, how can we make this more optimized? So the one approach that I can see is that we can use some optimizations and solve this using O of n. So how can we do that? So suppose, let's say we have 2 raised to power 5, 2 raised to power 6. Then what we can do is that we can find to the we can establish the faith that we know the value of 2 raised to power 6 by 2, which is nothing but 3, right? And the value of 2 raised to power 3, it's almost 2 raised to power 3 is 8, right? And then what we can do is that we can multiply, we can bridge it. 2 raised to power 6 is nothing but multiplying 2 raised to power 3 two times, right? That is how we can solve this. But is it true for each and every case? No. So when n is equals to even, then this is true. If n is equals to odd, then power of x comma n is nothing but we have to multiply one more x to this, x times. right? So this is true for, let me write this up here. So if n is even, then we multiply x raised to power n by 2 into x raised to power n by 2. And if x is odd, we multiply x one more time, right? So let's try to code in this part. Let's create another optimized power class, where what we can do is we find x raised to power n by 2, and we find is nothing but we multiply it 2 times, right? If n is odd, then what do we return? We return x times power multi, something like that. Like this is power multiplication. Else what we return? We return power multiplication. Right. So let's try to run this once and see. We have 2 raised to power 5, which is nothing but 15 times 2 is 32 almost. Yeah, that is the output that we get. So the time complexity for this will be log n, because n is 2 here, like for this example. So let's try to draw the stack trace for this, right? So if I copy this, let me copy it again and size it properly. Oops. Yep, and let's now try to draw stack trees for this. So let's consider that we are going to find x, we are going to find the solution for x is equals to 2 and n is equals to 5. Yeah, so I call power, let me write it here, 2 comma 5. Then what does this do? So let me number these lines, right? So this is line number 1, let's say. This is line number 2. Then this is the whole if condition is line number 3 where we return. So what we can do is first for the first line, when the first line is executed, like let's say when 1 is executed, what happens is it gives a call to another function. So let's call another function. We have power of 2 comma 5 by 2. 5 by 2 is nothing but 2. When the first line of this function gets executed, then what happens is we call another function which is power of 2 comma 1, right? When the first line of this function gets executed, what happens is we call another function again which is power of 2 comma 0, and this is where we had the base case, right? And this is where we return. So from here we start returning. And what do we return from here? So we return from here and we return with 1. Okay. Oh, what we return is we return with 1. We return 1 from here, and then the second line gets executed. So what does the second line do? Oh, the second line does, what does it do is it multiplies power, previous power with previous power, meaning it multiplies 1 with 1. So the output of previous multiplication is nothing but 1. And then what we do is we execute the third line, right? We, when we execute the third line, we have n as 1. So 1 mod 2 is 1. So what we return is, when the third line executes, what we return is x raised to power multiplication. So what do we return? We return x times 1, which is 2 times 1, which is 2. So we return 2 from here. Similarly, now we'll find power multiplication of, um, how will we find power multiplication? So power multiplication, like the second line will be executed for this now. So when the second line is executed for this, we find the power multiplication from the return value, and the return value is 2. We find power multiplication using previous power, which is 2 times 2, which is nothing but 4. And then we execute this. So now n is 4 here, sorry, n is 2 here. So 2 mod 2 is 0. So we just return power multiplication, which is nothing but 2. So for the third line, when it's executed, we return from here, which is, what do we return? 4. And then the second line is executed, which gives us power multiplication, which is nothing but previous power. The previous power returned is 4 times 4 is 8, right? And we again execute the third line that we have here. So the third line gives us n mod 2, which is 5 mod 2 is 1. So what we do is we multiply 8 times 2, which is nothing but 16, right? So the value that we will get from here is 16, which is our output. 8 sorry, 8 times 2 is almost 8. mm, right, but we didn't multiply 4 here, right? Like we didn't execute the second step. So my bad. This answer will be 4 times 4, which is not. Let me control C again. Yeah. So when 4 is returned from here, we find power multiplication. Let's continue from here again. So power multiplication is nothing but previous power, which is 4 times 4, which is 16, right? And when the third line is executed for this, we find the output that we want to return. Like this code will be executed. So 5 mod 2 is 1, and what we'll return is x times power multiplication, which is 16 times 2. So what we return is 32. So the return value will be 32. So that is what we were expecting, right? 2 times 5 is 32. So this is how we find an optimized way to calculate the solution for this. So let's try to run this for 2 to the power 5, and yeah, we do get the desired output. So that is all for this video. In the next video we'll be doing some more analysis on a zigzag problem that we have. So see you guys in the next one. Thank you.